In late 2019, one of the brightest stars in our night sky began to vanish. Not slowly, not over centuries, within weeks it had lost more than half its brightness. Telescopes around the world swung to face it, astronomers sent frantic emails, and the internet did what the internet always does, it panicked. People were asking, is Betelgeuse about to explode? The answer was no. But what was actually happening turned out to be stranger and in some ways more interesting than a supernova. And it was only the beginning. Before we get into what happened, let's talk about what Betelgeuse actually is, because the scale of this thing is genuinely hard to fit inside a human brain. Find the constellation Orion in the winter sky. It's one of the most recognizable shapes up there, the three belt stars, the sword hanging below. Betelgeuse marks his right shoulder. It's the slightly reddish-orange star in the upper left. You can see it with the naked eye, even from a city. Now, imagine replacing our sun with Betelgeuse. Its surface, not its atmosphere, its actual surface would extend past the orbit of Mars. Some estimates put it reaching nearly to Jupiter. Everything inside that radius, Mercury, Venus, Earth, Mars, gone, swallowed, just interior. It is roughly 700 times the diameter of our sun. And yet, despite being this incomprehensible monster, it is young, only about 10 million years old. Our sun, by comparison, is 4.6 billion years old and is roughly middle-aged. Betelgeuse at 10 million is already dying. That's because of the other number, mass. Betelgeuse is somewhere between 15 and 20 times the mass of our sun. The more massive a star, the hotter it burns and the faster it burns through its fuel. Betelgeuse is essentially running a sprint where our sun is running a marathon, and it's nearly out of road. Stars like this are called red supergiants. They are the largest type of star in the universe, and they have spectacular, catastrophic deaths. Between October and February of 2019 into 2020, Betelgeuse underwent what astronomers now call the Great Dimming. At its lowest point, it had lost about 65% of its normal brightness. For a star that's been a fixture of human skies for all of recorded history, mentioned in ancient Egyptian texts, named by Arab astronomers, used for navigation by sailors, this was deeply unusual. The immediate instinct, even among scientists, was, is this it? Is it about to go supernova? It wasn't. But the real explanation, confirmed later by the Hubble Space Telescope, was fascinating in its own right. Betelgeuse sneezed. I mean that almost literally. What happened is called a surface mass ejection, similar in concept to the solar flares and coronal mass ejections our own sun produces, but on a scale that makes those look like a candle flickering in the wind. A massive convection cell, think of a bubble of hot plasma the size of a large planet, rose through the star's interior and erupted through the surface. It ejected an enormous blob of plasma into space. As that plasma cooled and expanded, it condensed into a cloud of dust. A dust cloud so large it partially blocked our view of the star. We weren't watching Betelgeuse die. We were watching it cough up something roughly the size of several Earths and then sit there surrounded by its own debris. When the dust eventually dispersed, the star returned to normal brightness. Mystery solved, mostly. But then 2023 happened. In early 2023, instead of simply returning to normal after the Great Dimming, Betelgeuse surged. It became roughly 140% of its historical average brightness. For a brief period, it was the seventh brightest star in the entire sky, something it hadn't been in living memory. And alongside this surge, something else shifted, its pulse. Betelgeuse breathes. It has a rhythmic pulsation. It expands and contracts on regular cycles, the longest of which runs about 400 days. Astronomers have tracked this rhythm for over a century. It's as reliable as a heartbeat, and it tells us something fundamental about the star's internal structure. After 2019 and 2020, that rhythm was off. The timing of the cycles had shifted, not dramatically, but enough that scientists noticed. Some researchers have proposed that Betelgeuse might not be alone. The hypothesis, and I want to be clear, this is still speculative, not established science, is that there may be a smaller companion star in a close orbit around Betelgeuse. Something that periodically dives through the giant's outer atmosphere, disturbing the dust, influencing the brightness variations, and potentially explaining the long-term rhythm shifts that don't quite fit our existing models. Scientists have affectionately nicknamed this hypothetical companion the Betelbuddy. It's a great name, and the idea is interesting precisely because it would explain a lot of observations that don't have clean answers yet. If something is orbiting the star at close range, it could act like a cosmic metronome, a hidden influence we've been recording for years without knowing what we were looking at. To be clear, we have not confirmed the Betelbuddy exists. We cannot directly image anything that close to a star 700 light-years away with our current technology, but the hypothesis is being taken seriously and the search is ongoing. Whatever the outcome of the Betelbuddy search, one thing is not in question: Betelgeuse is going to explode. Not today, probably not in our lifetimes, though I'll come back to that caveat in a moment. But on cosmic timescales, it is imminent. Here's what's happening inside the star right now. The star shines because of nuclear fusion in its core, the relentless smashing together of atomic nuclei to release energy. For most of its life, a star fuses hydrogen into helium. Our sun is doing exactly that right now. When the hydrogen runs out, the core contracts, heats up, and starts fusing helium into carbon, then carbon into neon, then neon into oxygen, then oxygen into silicon. Betelgeuse has already blown through hydrogen. It's working through the later stages now. Each step in this chain produces less energy. The star has to work harder and harder to hold itself up against its own gravity. It's like a fire slowly running out of fuel. The flame burns hotter and hotter as it gasps for the last of what's there. The final step in the chain is iron. When a star begins fusing silicon into iron, the countdown truly begins, because iron is special. Fusing iron doesn't release energy, it absorbs it. The moment the core starts producing iron in significant quantities, the energy source that has held up the star for millions of years disappears. What happens next takes less than a second. The core, which has been supported by the pressure of fusion, collapses. Infalling material reaches roughly 25% of the speed of light before it hits the dense inner core and rebounds in a shockwave of almost incomprehensible violence. That shockwave tears through the star and explodes outward. A type II supernova. The energy released in those few seconds rivals the total output of our sun over its entire 10 billion-year life. The star is essentially annihilated. Now here's the part people always want to know. What would we actually see from Earth if Betelgeuse went supernova? The internet tends to get this slightly wrong. You'll see headlines saying it would be as bright as the full moon or would look like a second moon. That's not quite accurate. It would not look like a moon. It would look like a star, a point of light, not a disk, but a point of light so intensely, unnaturally bright that it would be visible in full daylight. It would cast faint shadows at night. It would be so much brighter than anything else in the sky that it would be disorienting. And it would remain at this brightness, slowly fading, for weeks or months. It would be the most dramatic thing most humans alive had ever seen in the night sky. And it would be a naked-eye event, no telescope required. Betelgeuse is approximately 700 light-years from Earth. The light hitting your eyes when you look at it tonight left the star around the year 1326 AD, the middle of the 14th century. Edward III was on the English throne. The Black Death hadn't reached Europe yet. That lag means something important. We have no idea what Betelgeuse is doing right now. The information hasn't arrived yet. The star might have already exploded centuries ago. If it did, we won't know until the light from that explosion finally reaches us. There is no early warning system. There is no alert. One day we will simply look up and the sky will be different. When that happens, whether in 50 years or 5,000, the light from a dying star that was already old when humans first recorded its name will finally complete its 700-year journey and arrive at Earth. There's something I find genuinely moving about all of this. We have been looking at Betelgeuse for all of recorded human history. Ancient Egyptians noted it. Arab astronomers named it. Sailors used it to navigate. It has been a fixture of human skis for as long as we've had skis worth looking at, and we're still learning what it is. We're still finding surprises, a possible companion we never knew about, a heartbeat that shifts in ways we don't fully understand, a surface that erupts and coughs and breathes in patterns we're only beginning to read. And somewhere out there at this exact moment, 700 years worth of light is traveling toward us, carrying information we haven't received yet. The final chapter of a story that started before our species had writing. We just have to wait for the light.